So we're using some graphs to relate to quantities. So the whole point behind this is to represent mathematical relationships using graphs, specific types this time around. And you see the standards that we're going to cover. Okay? For example, graph the size of Mrs. Coin's balloon over time. Okay? What we want to do is find some way to relate the size of Mrs. Coin's balloon as time lapses. Okay? And you see there, your graph's been filled in already. And so we're going to put time on the x-axis because time is going to constantly move. Okay? We're not going to scale the axis just yet, the x-axis just yet. It's because these graphs are just going to be sketches. Okay? But since we're talking about the size of Mrs. Coin's balloon, we're going to put that on the y-axis, and we're going to relate these two. In other words, as time progresses, what happens, how do we show what happens to Mrs. Coin's balloon? Okay? Well, apparently, this is what happened. Okay? All right? Now, the idea behind this is that this should tell a story. Okay? We should have a pretty good idea of what happened to Mrs. Coin's balloon. Over time, right? So what may have happened? Got bigger. Why? Why did the balloon get bigger? So we started here, and the balloon got to here. Why? What happened? Huh? People put air in it. Mrs. Coin put it. How did she put air in it? Henry?
They were air into it?
Yeah, okay. She started to blow it up, right? Okay, and it stayed this size for a couple of seconds maybe. Then what happened?
Some of the air came out.
Okay, so then what happened, do you think? You're right. The graph says that some of the air came out. Why would some of the air come out?
Because she had to take a breath.
Okay, good. She had to take a breath. Didn't hold the balloon tight enough. Right? So some of the air came out. Then what happened?
She started
Took a big breath, blew some more air into it, right? Got to here. And then what happened from here to here?
She tied the balloon.
What's that? And then it popped. Okay.
Or it lost air.
Pretty good. Or it definitely lost air. Maybe it popped. I mean, we don't know for sure, but it's a pretty good, reasonable explanation, right? It popped. It definitely lost air a lot quicker than it gained air, maybe. Kind of looking, this is a rough graph. Okay? But yeah. So we want to make sure that we show some representation of what happened in that scenario. Right? Okay? Okay? For example, sketch a graph that shows the height of a ball. Sketch a graph that shows the height of a ball as a function of time. Right? So I have a ball. I'm going to take it. I'm going to throw it up. And as time lapses, what's going to happen to the height of the ball? And then we should be able to find a way to show that graphically. Right? So as a function of time, what happens to the height? Okay? What's that graph going to look like, you think? Jaden, what do you think? Going to go up and down a lot? How many times is the graph going to go up and down? Okay. Okay. I see what you're saying. That's a pretty good idea, right? So what would that look like? So we're going to throw the ball up, right?
Yeah.
The height might be, let's say I throw the ball up. Might be as tall as whatever I am, right? It goes up. It's going to come down.
Yeah.
To here.
Yeah. And it goes back up
To about half.
Yeah.
Just a high bouncy ball. And come back down. Okay. It's going to keep doing that. Okay. And eventually it's going to stop. That makes enough sense. I wasn't thinking about the ball that way. Thinking more of maybe like a hacky sack where it kind of comes up and just... But the ball bouncing makes a lot of sense, so we can stick with that. Okay? Obviously, this is your graph, your sketches, and these are just rough sketches. They're going to depend a little bit about how you perceive things. Okay? What about the length of a candle as it burns?
You put time
Okay, yeah, we're still going to put time over. We're always going to put time on the x-axis. We're always going to want to graph as a function of time. Time is going to be our input, our x's. We're talking about the length of a candle as it burns. What do you think it's going to look like?
negative line, just straight.
Okay. Like that. Negative line. Hang on to that. We'll talk about that later. Okay. Something like that. It's going to burn. It's going to, the length is going to decrease pretty constantly, right? Okay. So something like that. How about this? Think about this for a second and get yourself a nice sketch if you haven't already. But the water level in a toilet over time. And let's assume that the toilet gets used at least somewhat. It gets used a few times anyway. I know this sketch could very much depend on which toilet you're talking about. Whether it's a toilet in my basement where nobody ever goes down there. Right? Versus a toilet here at the school where it can get used 100 times. Okay. How about just a toilet in your house or something? I don't know. Okay. Just trying to get an idea here. What would that look like? Gary, what do you think? What would that look like? Okay, does. Where's the graph going to start? Is it going to start down here? Up here?
Probably
here?
Top.
Okay, probably towards the top. Okay. What do you think? It's going to be kind of go across like this is going to be time. We always need to label our axes. Time and level. So we're going to start it here. Then what's going to happen to it, Gary?
Would it decrease?
Okay.
And then go back up halfway.
Halfway?
Yeah.
Okay. Then what?
Maybe let's say the same. And it would go
Slowly. To where? Up here again? To the same level as it was before? Yeah, that's what happens, right? Maybe it doesn't stay the same for as long. Then it stays the same again, and then same thing, right? To represent someone flushing the toilet, right? Something like that. That's pretty good. Okay? That's true. Again, not something I had thought about the first time through, but yeah, I mean, typically speaking, the water level will come up a little bit, and then as the tank fills, so does the toilet level, right? So it doesn't go right back up to the same level as it was before necessarily. It kind of depends on the type of toilet, I guess. Okay, something like that. Okay, good. Now, what we'll do is, it's like just kind of give you an idea of what a graph should kind of look like, sketch what it should look like. Okay. Now, what we want to be able to do is take a little bit more specific story and sketch a graph based off of it. Okay. Now, to make sure that your graph matches up with your story, we have to know the story, and so the previous graphs were just based on our own experiences and things like that. Our graphs could look too different. But then we take a story now, and our graphs should look basically the same, right? Maybe not exactly the same, but basically the same. Now, to help you in creating your time graph, it would be helpful, I think, to go through the story and sort of highlight the different events that might make your graph change, right? So you're thirsty, you decide to get a drink of milk. You get a glass out of the cabinet and start to fill it with milk. Okay? So we're going to start to fill it. When the cup is about halfway full, the phone rings and you stop to answer it. Okay? After a 3-minute call, finish filling the glass. Okay? Maybe even this. I know that your notes are already filled in for you a little bit, but we're going to start to fill it with milk. When it's about halfway full, you stop to answer it. After a 3-minute call, you finish filling it. Okay, take a few sips and decide you want chocolate milk instead. So you stir in some chocolate syrup and then gulp down the rest of the milk. Sketch your graph. Okay, sketch your graph. All right. Well, you see that, right? When you pull the glass out of the cabinet, and again, we're going to make this time versus amount of milk. Yep, milk level would work. Okay. So you pull the glass out of the cabinet, there's not going to be any milk in there, right? Hopefully not. And you fill it halfway full. You stop, phone rings, you stop to answer the phone. Right? Then you finish filling the glass. Take a couple sips. So what's going to happen to the milk level when you take a couple sips? It's going to drop a little, right? Then you decide you want chocolate milk, so now you're going to put chocolate syrup in your milk. What's going to happen to the level then? I don't know if it necessarily will go back up above the original level of the milk. It kind of depends on a lot of things, right? Okay. And you got your chocolate milk, and then you decide to down the rest of it. Okay. Most good for you.
Makes me sick.
Not good for you. Okay. So the graph should look something like that. And that's roughly what your graph looks like on your paper there. Okay, but that's the idea. right? Find the words that are going to change your graph. Make sure that you get every change in that graph. Okay? So give it a shot. Mrs. Fife is going out with her friends. She leaves home, travels at a steady speed to Mrs. Hall's house. She stays at Mrs. Hall's house for 20 minutes, then drives to the mall. On the way, she gets stuck behind a street sweeper and slows to a crawl. She finally arrives at the mall. She shops for 60 minutes and returns home and sketches the graph. Give it a shot. Think about it. Come up with your graph, and we'll see what you come up with. Okay? Let's see. Okay? So let's adjust. I like most of what was there. Let's just adjust slightly. Okay? I would suggest this is her distance from home. If she's at home, what's her distance from home? If she's at home, what's her distance from home? Right, it's 0, right? So you could have even, Grace, you could have even started down here on the x-axis if you wanted to, but you're down there pretty close. Okay, so I like what she did. So she said that she drove, stopped for a while, right? At Mrs. Hall's house. Okay, and she did a good job of highlighting a lot of the stuff that she wanted to make sure she showed. Now, the only issue, and she admitted she had a hard time coming up with how to show a slower pace. She had to slow to a crawl, right? Because she got behind a street sweeper. If this guy right here was her driving to Mrs. Hall's house,
wouldn't it be like...
Well, that's what someone else thought too. It doesn't say that she would drive and stop, drive and stop, drive and stop, right? It was just at a crawl. So Isaac...
Lower the angle.
Okay. Not quite as steep a line, right? Yeah, lower the angle. And we'll talk about slope. Probably not the first time you've heard of the slope of a line, right? But it should have a little bit less slope. Right? A little flatter. Does that make sense? Then she gets to the mall, spends some time there.
You spend 60 minutes.
How did she just spend 60 minutes at the mall? Being a woman. Sorry. Is that out loud? My wife could definitely kill more than 60 minutes at the mall. But anyway. So the graph could look something like this. Okay? So you can adjust speed and things like that with the steepness of your line. Okay? And again, guys, we're learning. Don't worry about it. Okay? All right? I got another one here. You're on your way to see a movie with a friend. Since your friend lives on the way to the theater, you drive, leave your house and travel 30 miles per hour to your friend's house a few blocks away. Okay? She's putting on makeup. So there's some things that are going to change your graph here. Take a stab at that one. Okay? Right. Yeah, we don't really want our friend to... Okay, we don't want to shove our friend out the door.
Bye.
That's right. Okay, but I think pretty good. And so, again, we're going to label time, then distance. Okay, we're going to start out at home, go to our friend's house, wait for 20 minutes, realize, oh my gosh, you made me late. Drive a bit faster, watch the movie, take your friend home. Be nice to stop the car, and then get home. Okay? Something like that. And again, it should have the same sort of stops and starts and whatnot, but it could look a little different. Okay? Good. All right. Now, we also want to work backwards. We also want to be able to take, so the whole point in displaying this is to describe what happened in a given situation. And so we want to be able to take a graph and tell the story. So we want to work backwards. We want to be able to work backwards as well, right? So the graph below shows a plane's altitude during a flight from Denver to Vegas. Write a story to explain the graph, okay? And as we write our stories, some things we might want to keep in mind, right? One, we want to make sure our stories are school appropriate, okay? And as much as we might want to try to be a little funny and a little cute with these, sometimes you can get yourself in trouble. At least the previous class did, as far as losing your way, losing the path that you were on and writing the story. So just, this is the KISS philosophy, right? Keep it simple. Keep it simple, silly. Okay? Anyway, so what we want to be able to do, and you see it there in your notes, is take the graph. So, pilot took off, right? And then stopped climbing for a few minutes, right? And it could be for whatever reason. I think your notes suggest that he or she's trying to avoid a cloud. It's fine. Okay? A big flock of geese or whatever, you know. But they stopped climbing for some reason. You want to put that reason in. Could be anything. Mad Libs, right?
Because they reached.
Okay. Only not yet, right? Not here. Now, they did have to keep ascending, and then they reached their what's called cruising altitude, right? Every flight will do that. And then, for some reason, the altitude dipped pretty quick twice, right? Didn't drop down and stay, but just kind of dropped down, came back up, dropped down and came back up. Okay? Again, could be a lot of reasons for that. And that hopefully is what's going on, right? Not just the pilot having a little bit of fun in the 747, okay? Right? So yeah, turbulence is probably the best explanation for that. And then they get to the cruising altitude again, everything kind of smooths out, and then they descend down, okay? So you should be able to take the graph and work your way into a story, okay? And that's an example of that. You give it a shot, okay? This graph shows the water level in a tub as a function of time. Write a story that matches the graph, okay? Again, keeping this school appropriate, okay? All right, so start filling the tub up, right? And you stop. And why did the water level stop?
Stop filling it. He went to go get the bubble bath.
So he turned off the water to go get the bubble bath?
Yeah.
Okay. Then what happened?
Turns it on halfway and then turns it off to get his favorite rubber ducky.
Okay, so he started filling the tub again. He forgot something else, right?
And then he turns the water all the way on, stops to take his bath, and then lets it out fast, then slower because he wants to play in the water.
Okay.
That looks like
What would explain this?
he got into the tub.
Okay, everything's fine. Okay, here. What would explain the difference in the speed of the water level and how fast it goes up here versus there?
Him getting in.
Okay, good. Good. So, started filling the tub, forgot something, bubble bath, had to turn the water off, go get it, right? Came back and started filling the tub again, realized he forgot something, stopped the water, go get it, whatever, rubber ducky, it's fine, okay? Went and got it, okay? Or better yet, right? Started filling it, forgot something, went and got it, filled it the rest of the way that he wanted it. Okay? Went and got his rubber ducky or whatever. And then, yeah, I like that. He got in the tub. That's why the level jumped up so quickly. Right? Right. And then he took his bath. And then we could use the same thing. what Jaden said, right? Okay, then the water level went down here pretty quick because he got out, right? And then opened the drain, and the drain drained the rest of the tub out. Okay? Good. Something like that. Okay, that's good. As long as you have an explanation for each of the different changes, right? And then an explanation for each of the different stops. Okay? And as long as it makes sense, I think you're okay.
I just didn't put his body into consideration.
Okay. Yeah, you had to actually get in, and it's definitely going to jump the tub up, right? Okay, good. That's pretty good. You got one more chance here. How about this? What's happening in this graph? If you haven't gotten your story in yet here, go ahead and take a second. Okay. Isaac, what happened?
Alright. Antoine started walking home from school.
Okay.
And then some Jehovah's Witnesses started talking to him for about 30 minutes. And then he got impatient and ran away.
And ran away?
And then
Okay.
he ran out of breath. And he took a breather. And then some
That's
muggers.
a long.
And some muggers got him. So he had to fight them off for about an hour.
An hour?
That's, alright, that might be 30 minutes too. Alright, that's 30 minutes too.
And then
Okay.
so he fought them off for like 30 minutes. They ran away. And then he started taking a slow walk home. And then he saw his girlfriend. So he agreed to his girlfriend for a little bit.
Oh, there's a third stop?
Yeah, there's a little stop.
Yeah, there is.
Yeah, seriously? So he like drove to his girlfriend and walked away.
Okay.
I think that's just a given.
Yeah, I think it's just the way the line is drawn. That's okay. Okay? All right. All right. Sure. That could certainly be what happened, right? Again, you need to include why there's a difference, right, in those two speeds. You need to include two reasons why there are stops. Okay? And then talk a little bit about just getting home. Okay? That's good. That works. All right. Any questions? Any questions about that at all?